All right, so here we go. This will be another example. What we're given here is our chart of activities, and this is the list of the predecessors. So if you see a line there, that means there are no predecessors. And then these are the durations, and then you could think of those as like hours or days or whatever. Good. So what we want to do is we want to draw the diagram, the network diagram, and that's with activities on nodes. And then we want to find the critical path. That is by computing our values here. You remember what they were? Activity, duration, early start, early finish, latest start, latest finish. By the way, this I think is a nice way to write it, but some people will put like activity and duration in the middle. So whenever you run across one of these diagrams with these numbers, be sure that you look to see what they mean, because people will rearrange these ordering pretty commonly. All right, so let's get started. So we start with the stuff that doesn't have any predecessors. A, good. And then, of course, B depends on A and C depends on A. So how do we draw that? A must go to B and to C. Good. By the way, I drew these lines after each two nodes just so that it's easier to read. Okay, there's no other reason why there's these horizontal lines here. It's just for readability. Good, let's continue. So how would we finish this off? D comes after B. B and C come after E. So let's see. I need E, B, and C have to come before E. So can I put E here? I think we could put E here. Let's go ahead and put E here and see what happens. So then B would have to be here and C would have to be there. Right? And then F depends on C. Oh, I guess I could put F down here. Would that work? And then G depends on E, D. Okay. G depends on all three of these being done. So I could just stick G right there. And I think we have our net. Okay, now this already has a nice starting point and a nice ending point. So I'm going to leave the start and finish off. If I had like if the B didn't have another predecessor, if I had started with an A and a B, like this without any predecessors, then it would be a good thing to have a start node with 0 duration, just so you're connecting up the dots here, okay, connecting up the durations. All right, so I'm going to go ahead and redraw this in a little bit bigger fashion with our 6 numbers. And so let me pause this. All right, so I've got the diagram kind of set up here real quick. So let me go ahead and put in my activities with durations really fast. We'll take our B and our 7. C will be 5. D is 8. E is 5. F is 2. And G is 1. Good. Now we're ready to start our forward pass. So A is going to start at 0. And then 0 plus 4 is 4. Good. Now B had to wait for A, so therefore the earliest start time for B is 4. 7 and 4 is 11, and that is the earliest finish time for B. Similarly, C. C has to wait for A, so it has to wait until 4 units to start. 4 and 5 is 9. Very good. Now let's go to D. So D has to wait for B before it can start. Right? It doesn't have any other ones to wait for. So therefore, D has to wait until 11 to start. 11 plus 8 is 19. Good. Now E. E is a little bit more interesting because it has to wait for both B and C to finish. So therefore, what is its earliest start time? C can finish at 9 units, B at 11. So E must wait until, did you say 11? If you did, then you are correct. So then earliest finish time is 16 then. Oop, my 11 is hard to read. Good. And F has to wait for C, so it has to wait for 9 units. 9 and 2 is 11. Very good. Now, I think we're just about done. We're at G, right? G's got to wait for D, E, and F. So therefore, let's see, that's the difference in waiting between time 11, 16, and 19. Which number is going to go there? Right? It's the biggest of the three, right? So the earliest time that G can start is time 19. And so the earliest finish time is 20. And we're done. That is our forward pass. Okay, now do you remember how to do the backward pass? You might pause for a minute and see if you can do the backward pass. Okay, are you back? Let's go ahead and do it together then. We're going to write our 20, and so 20 minus 1 is 19. And so that's our last start time, latest finish time. Good. Now D, in order for D to finish, well, in order for activity G to start on time, G has to start by time 19, right? And so that means that D must be finished by time 19, right, in order for G to start. Good. And so then the earliest or the latest start time for activity D would be 19 minus 8, which is 11. And you might notice that those numbers are lining up. That has significance before, right? Similarly here, activity E needs to finish by time 19 so that G can start. So that is its latest finish time. And so 19 minus 5, what is that? 14. Okay. And then down here, G is 19, so F must be finished by time 19. 19 minus 2, 17. Good. All right. How about B? B has to be finished in time to let these two activities start, right? So is it 11 or 14? Well, remember, if B finishes at time 14, that's going to make D late, right? So therefore, B has to be finished in order for D to take over. And so it's the minimum between these two, like we were saying. And so that's going to be 11. And so 11 minus 7 would be our 4. Okay. Similarly for C, C has to be finished in order to let these two guys go. E can start at time 14, well, has to start by time 14 in order to make this 19. F can start at 17, so therefore C better be finished by time 14. Good. And then 14 minus 5 is 9. So everybody seeing how that works? Then finally, activity A has to finish in time for B and C to start on time. So B has to start by time 4, C has to start by time 9. Therefore, A better be finished by time 4 so that B can take over, right? And then there'll be a little bit of slack here, right? And that's what we were talking about before. So this has a slack. This has a slack of 0. This has a slack of 5. This has a slack of 8. A lot of slack there. Slack 0. This has a slack of 3. This has a slack of 0. Everybody else done? Slack of 0. So now do you remember how to find the critical path? It is the set of nodes with no slack. So therefore we're going to go from A to B. Let's see, that has a slack of 2, so that's going to go to slack 0 here, right? And then we go to G. Good, so that is my critical path. Good, so that is an example from start to finish. It only took us 10 minutes. Hey, that's not too bad. All right, So that's it. There'll be so the homework is just going to be almost identical to what we just did. I'm just going to give you activities, predecessors, and durations, and so you're going to draw the network diagram, and then compute these 6 numbers for each of the nodes in the diagram. So remember to do ES and EF, you have to go forward, and to do LS and LF, you have to go backwards. Good. And then finally, you want to find the critical path by computing the slack. And the critical path is the path that follows the node slack equals 0 nodes around. Excellent. All right. I'll see you later.